Okay. All right.
Lovely.
So, yes.
Right.
So,
We are recording this session now. Welcome to another amazing session from our Nebula program. We are running the cohort 3 now. And today we have Saranjeet giving us intro to the open tools and resources. And I am absolutely looking forward to the learnings, what we are going to hear today. Today I will be your facilitator, Sayantika, and I have lovely Gracieli to make sure that I do not overrun or do something unexpected right there. Apart from that, some logistics that we would love everyone to take a peek. Most of you would already know about it. The first thing is we are recording this call and transcribing. The videos would be available on the YouTube channel. More information could be on this could be picked up from the Slack channel and the updates on when it's going to be released, things like that. You could also enable the captions from the Zoom itself, should you wish to do more live captioning and not wait for when it comes on the YouTube. We have a code of conduct and the community guidelines. The link is on the Pad. Should you feel uncomfortable or come across situations which violates the code of conduct, please reach out. There is the reference to the email link, and we are also here immediately to respond. So reach out to Sarah or Graciele via the email or via DM, the medium which makes you comfortable doing that. And any issues which you might be facing, there is also an email provided right in the farmer pad by the line 43. And today's session, we will have the presentation followed by a couple of prompts and activities, which we will run through as we continue during the session. And I'm going to shut up and give the stage to Saranjit to take over. All yours.
thanks, Santika. Thanks, Graciela, and also to OLS for inviting me to share my thoughts on green tools for open science. Um, basically, it's always tricky for me whenever there are online sessions because I cannot really see who is in the room and get an idea of if people are following along. But if you do have questions throughout the session today, please feel free to use the chat, the Zoom chat, and drop your questions, and we'll try to take those as they come along, or at least at the end of the session. So what we are going to discuss today is general tools that you can use to make your research more open and follow best practices in open science. And specifically, we are going to focus on uh, what is metadata, why documentation is important for your projects, what are repositories, and what are persistent identifiers. So we are going to touch on all these points and then try to understand what are the different ways to use these in our day-to-day research work. So uh, for this, I'm going to share a few scenarios that we come across in our research life. And the first scenario is let's imagine there's a library and you want to go find a particular book in the library. So when you do go there, what you would try to look for is, or tell the librarian about the title or the author or the subject. And then the librarian tries to tell you where the book might be located in the library. So this kind of information, which is data about the data, is called as metadata. And metadata is something that's useful to find, understand, or organize the data. So either a metadata can be embedded with the data itself, or it can be separate from the metadata, from the data, sorry. So what kind of information is usually available in metadata? So in terms of if we are looking at metadata of a particular data set, then it could include information about when and how was that data collected and processed, what kind of parameters or variables are included in the data set, who collected the data, say which organization or which team collected the data, how it can be cited, and it can also include some spatio-temporal um, uh, information or any legal guidelines or information about this data. So this kind of information about a particular data set is called as metadata. It's quite useful to have metadata. One of the most important uses I feel is that it's relatively easier to share the metadata instead of sharing the entire data set. Uh, Not just in terms of the size, but sometimes also the entire data set may contain restricted information. So it might be easier to share the metadata instead. And uh, also there is a benefit of it being smaller in size. It also is useful, like in the library context, when you know the metadata, you can search the data that's associated with it from an archive because you know what the metadata is. And then there are different types of metadata. So some of the examples include a descriptive metadata. So a descriptive metadata would be something like it's giving the variable definition or the data limitation. For example, if we think of descriptive metadata in a paper, then it would include things like the abstract title or keywords. So in this image over here, it's a screenshot of a JOS paper, and it is giving us all these metadata around what is the title of the paper, what tags are associated, who are the authors, what are they affiliated to. So these kind of information are available or can be classified as, descriptive metadata. The other type of metadata is the structural metadata. Um, a structured metadata will describe the structure of the data as the name suggests. So this could include what is the format of the files inside the in the data, what kind of dimensions these files have. So a very basic example would be it's a bit outdated, but a very basic example is the structure metadata of a folder in your laptop. So the names of the files and information on their dimensions and the type of the file. So those kind of information can be classified as structural metadata. And another type is the administrative metadata. So this would include things like for example, for a software package, it could include things like when was the package created, um, what is the version of the software, and which software was used to create this, which other software was used to create this piece of package that you're talking about. So those kind of things could go under administrative metadata. So yeah, so what um, what I would like to point out here is we often come across metadata whether we recognize them or not. But whenever dealing with data sets, whenever dealing with research projects that involve data sets, you are coming across metadata every now and then. So I would like to pause here for a few minutes and would like to ask you to reflect on if there are any metadatas that you can think of based on the different types that I just mentioned, be it administrative, structural, descriptive. And if you can think of some, try to make a note, and you're also welcome to share on the chat, and then we'll reflect on it a bit later. So just a couple of moments to think of metadata in your day-to-day life, research life.
This is an individual.
Yeah, this one is a reflective, self-reflective individual exercise. Yeah, we don't need pickup rooms.
Lovely. And that means you have all the time to think and come up with really interesting answers for us. We will discuss them not only in the perspective of how this actually impacts the world outside, but also it's impacting you. Like, why do you even really need metadata. Is it helpful? Did you find any instances that you can come up? Any of those interesting answers, experience are most welcome. The link on the Frama pad is starting at line number 53, where you can note these. If you have more questions, you can drop it from the line 60, and we will take those questions and your answers together after like few minutes of silence. And I'm dropping the link to Josh because I am a reviewer there, and it is a really cool space to find the open science work that's been going and what's new and upcoming uh, areas of research that's coming up. There you go.
Where did you say people are putting line number 53 or? Okay, I think it's 53.
I'm gonna recheck. Yes, it's 53 that
Mhm.
we are currently on. And it will take like 2 minutes. And in the meantime, you have the chat, you have the pharma pad, or you can come unmute and share your ideas with us. Either of them, all of them, welcome. Oh, we have a timer. I love that. The magic is happening in the background. Okay. I do not have to take care of it. It slips. Sanjit, do you have any areas and experiences which you might want to share with us, which was really helpful with and without metadata? What was it like? And what are your challenges in there?
Um, yeah, I think these kind of things become really useful when, for example, I'll take the example of the software package. And when you're trying to find things like on what packages does a current package depend on, or if something is outdated, it's very useful to go and read those kind of documentation and those what other dependencies are is the software pointing to. Um, uh, I think not so much now, but especially when I started using software or software packages or started building, like writing my own code, and when I was really new to the journey, it really helped me understanding all these documentation and where they sit and what they depend on. Because early in my journey, I didn't understand a lot about dependency management, and I used to mess up my code, and often would end up looking for places or resources of okay, why or what did I miss here? So yeah, I find that really helpful now that I know better, a little bit better than when I started. Um, yeah.
So that funny thing that comes and bites you afterwards, and you do not realize that how painful the journey could get should you not pay a lot of attention in the day one itself. And your
Mm,
dependency management, it's still a piece
yeah, it's
that is so critical. And I see my GitHub every morning coming up with these package updates. Like every downstream impacts that happen, not
yeah,
just one package comes down. Then you do the resolving. Okay, Mama can do it for me. And then Mama kind of doesn't do the job. And then you manually find out which patch works for which version and continue to do that unless you have that idea and mental model built that next time you're going to take a stable version and connect it to the downstream, and it will do the best job for you.
Mm-hmm. Yeah, I think it also gets really so maybe like when you're starting off with a project, you don't see the importance of like really making sure things are in place and you know what you're trying to work with. But as the project evolves and as it becomes more and more complex, if you have if you have not followed good practices, if you don't know how to deal with these kind of situations, it can get really, really tricky after a while. So, to begin with, I wouldn't say like at this time point, everyone needs to learn all the good practices in one go, but at least having that awareness of, okay, these are the important things and these are the bits that at least you should be aware of when trying to implement these principles is I would say is a good start.
Absolutely. Building that mental model from the day zero, I say security, compliance, metadata. Do
Hmm.
not keep for the day 10.
Yeah.
It will become a major task and a client to solve.
Hmm.
Lovely. And we see a lot of action on the Pharma web, which is amazing. And we do have some seconds left on the clock should you wish to come unmute and share your thoughts with us. And no stress. Absolutely.
Hmm.
Um, we are gonna share your thoughts as I'm gonna read them pretty soon. As wow, yeah, very good points there. I'm gonna start summarizing and maybe for all of us to have a look onto the notes.
Hmm.
The first one I read is I came across descriptive and structural data set in my normal work routine. Great. And that does add like in our day-to-day job and work that we come across a lot of these bits and pieces. We might not deep down and frame in our mind, but we do come across them. For structural metadata, I often just go to the properties of the dataset to view its metadata. Fair enough. Property is a good space to find that information. And I love the third one, which is still running on my screen.
Yeah. Yeah, I completely agree. Like even the third point where you tend to use it and you're not aware of it until someone points out that this is actually the metadata. Yeah, I think it happened to me a lot when I was like starting out into using open data sets and open software.
Lovely. One which is by default could be integrated with your data itself, but sometimes the sources are much different and it keeps changing. And the source of truth also keeps differing and having a consistency in some or the other way. And we will learn about them. What are these mediums of consistency that you can incorporate in your respective data or any field that you're working? So though they change, you do have a visibility of how, when, why. Those questions, just having those awareness pointed out there. Very cool. Credible journal articles. That's definitely space where metadata is profoundly useful. Lovely. All of these thoughts, right from our day-to-day life to our respective domain knowledge to actually having this information collated in a structural format is crucial. I think this prompt and your answers really point out to that this is important. And we will move on to the session and presentation, Sanjit, so we can come across our next.
Okay, cool.
And please keep it running. Your answers are always, I'm gonna keep an eye on them and we will discuss. So keep the thoughts running in there. Do not stop.
Yeah, if there are any thoughts that we didn't touch upon, there is a space at the end for open discussion and we can come back to them again. But now I would like to move to another scenario. And this scenario, let's see if you can guess what I'm talking about. So, say you're a researcher and you have been writing a lot of code for a particular analysis that you have been doing. So, you write all this code and your work is done and you're happy with it. And then you submit it to, say, a journal, or let's say you submit it to a conference. And after 6 months, your submission is accepted, and now you would like to present your work at a conference. And now you go back and look at your code. Um, and unfortunately, you cannot remember why did you write certain lines of code, or where is a particular parameter coming from? What was it supposed to? What was the description of this parameter? And there are also lines of code that are breaking. So now you are in a very panic situation where your work has been accepted, and unfortunately, you cannot remember a few things about your code. So, what really happened in this situation was you forgot to document your work or you forgot to document your software or data when you were working or building with it. So, always remember to document your work as early as possible, because it really helps save your future self, and it helps to avoid ending up in situations where you've forgotten things. Um, there are quite a few benefits of documenting your work. For example, if you're regularly documenting, you can use that as a you can essentially reuse whatever you have written in the future. So you can take reference from what was written in the past, and you don't have to really take the mental load of remembering things. For example, for me, if I'm developing a certain piece of software, I'm sure to forget within like a week or so why did I write a particular line of code. So um, writing the documentation at the time that it is being developed is something that I've started to implement a lot in practice. I think that I've also read a few resources on documentation-driven development in software, and where like documentation is given the primary importance when building the software, and then that way you don't really have to recall a lot of details of the workflow that you're building. Um, so now let's think of the different ways where you can where and what you can document. So, for example, when you're talking about documenting the data, then in such a documentation, you can include a summary of the data that can answer questions like um, how can the data set uh, be used, or where was this data set collected from? Are there any associated publications with this data set? For example, is there another research group or another research project that use this data set? Are there any known errors of this data set? This is again very important. There can be data sets are recorded and there can be inherent errors that come along with the data set. So if you have noticed an error, it's always nice to document it along with your data set. And then all these information, either you can put it in the README, but again, there can be a limitation of how long you want the README to be. So in that case, you can also develop like a user-facing guide for people who would um, who would want to use your data set, or just generally for yourself in the future. You can create a guide that has answers to these questions recorded. So in the example here, I'm sharing a documentation of the uh, photovoltaic solar panel energy generation data by UK Power Networks, and you can see that they have documented key stats of the data set, as in how many substations the data set was recorded on, how many days it was collected over, what was the duration from to when the data set was collected, and then some more details around the granularity of the data, and uh, the source. So this kind of documentation gives you a overall picture of what to expect in the data set and what's the original source of this data set. Then talking about documentation of software. So documentation of software can take different forms. The most um, central one, I would say, or most the one that's immediately comes out is the README files. So, for example, if your software is hosted on a remote repository, let's say GitHub, GitLab, or any other hosting platforms, then it is very nice to have like a README file included with that piece of software. And in this README file, you can give information of how someone new to your software or someone just looking at your software can start working with the software. So things like how can, if the software needs to be installed, then how can it be installed? Here I've given example of a R Shiny package, but this could be anything. This could be any other package. So how to really install this package, if this installation differs across different OS operating systems, then you can give details on that. Also, a very nice thing to do in the README would be, if possible, try to provide a simple working example. So once someone has installed the software, what's a simple minimal example that they can run and see that everything is working fine. So giving that example is also very useful. So that's about your README. There are many more things you can include in the README, but at least the basic installation and usage instructions are very useful to have. The other thing you could include is in your software itself is inline comments. Wherever possible, uh, give these inline comments or use doc strings. There are several packages that are useful and that can be useful to do that, like the R oxygen package in R, and then you can also write doc strings in Python packages. The other place to document your software are the release notes. So release notes, again, this is something you would do as your software goes through different phases. So as there are major or minor releases of your software, you can provide release notes, which include information on what is new in this version or what has changed from the previous version. And then you can also document, I have not included here, but you could also document how people can contribute to your software. You'd like to have, um, uh, if you'd like to have contributors on your software, then how can they get started doing that? So you can provide contributing guidelines. And then the other two things that I would recommend including would be technical guidelines. So technical documents for your softwares for future developers and also for you in the future. You can create technical documents and then also user-facing documents for people who would be consumers or users of your package. So those are other types of documentations that you can develop, and then the kind of things you put in both these so the technical versus the user document would differ slightly. For example, it might be nice to include a lot more examples and use cases in the user facing document, whereas with the technical documents, you can go more into the technical details about the different parameters, arguments, APIs that you've used or developed in your software. Okay, and then the other one is documentation of results. So I think this is this would be about writing things about what was the actual research process like. So you can write all these reports about the process itself, about the packages that were used or the software that were used, so that so documenting the process or the results, it would help also with the reproducibility of your work. So making sure that you write down the steps, and then if somebody in the future wants to replicate what you've done, then they can follow the result documentation that you have created. Okay, time for another short reflection exercise. And this one is about finding a piece of documentation for a data set or a software that you use often in your work. And if you don't have one, you can also reflect on what kind of documentation you would like to include in your day-to-day research work. Yeah, I'll stop sharing here and then see if
Most of my work and understanding of documentation is like I want a place to journal, like just how I do on a piece of paper. I feel software is no different, just in terms of it's not tangible in that scenario, but it still tells a story. It evolves, it connects systems around it. It kind of we are going in the age of AI, so it's gonna be sentient very soon or never. Debatable question. So it's a medium for us to understand why a software was created in the first place. What was the journey of the software? What were the changes in that sense? And I really like the differentiation between the user-facing documentation versus the developer documentation. For me, commits and all the information that I associate with my work is for me to look at, like user-facing. While I do a release, sorry, for me as a developer, but while I do a release and add a release number and the notes and my contributors and the change log in that, it is for the users on the other end who has been consuming the work that is being done. And that's a difference. One software could be built for yourself, but when you want to scale it or build it for the world that is going to consume it, you need certain information or bullet points for someone to actually start contributing to it. How do I even install that package? What are the dependency sources that is needed? Is Windows installation different from Linux installation? Is Mac OS gonna have the M1? If I have Apple chips, if I have the older chips, is there gonna be a different ways if you're a compiler levels? All these nuanced understanding of your software would be highly beneficial if we have a documentation to run through. And I forget all the commands all the time. All my demos, I'm gonna proudly look at my documentation, copy that command that I forgot, and then run it on a live demo. And I'm like super happy that I did that documentation and it's still working on a live demo, and voila.
I
Good
think we
job.
all
Good
do
job.
that at some point, like we all forget things, and I refer back to what I've written in the past. So, or the commands, yeah, I keep forgetting them all the time. Also, like if,
Was it?
yeah,
Go
sorry.
ahead. No, please go ahead.
Also, like when you start working on multiple projects, say if you're just working on one project, you might rely on your memory to like remember how you worked through the whole thing. But as soon as you start working on multiple projects, and there's a lot of context switching, it's really, really useful to have those documentations in place. For example, if you're working on 3 projects at a time, say 1 week for 2 days you're working on certain thing, and then for the other 3 days you're working on a different project. If you don't have that documentation in place and you're expected to do a lot of context switching, uh, it, you don't end up in a good place, I would say. So it's really useful to have um, those documentation written. I think the other point I wanted to mention there, which I missed during the slides, was if you don't know what to document, or if you really don't see that your software needs or your data set needs some kind of documentation, then for example, if you're running your software package or if you're using your data set at a certain workshop or to present it to somebody else, and in that process, if people keep on asking the same question to you again and again, okay, what do I write to say install XYZ, or where can I find XYZ? So if you're getting the same kind of questions again and again from the users or consumers of your software or data, that's a good indicator that this information is missing or this information needs to be documented. So use that as an indicator to um, again, don't overwhelm yourself. You can always start with the README. So start putting information in the README, and then as you start developing that skill of noting down things, you will also spot areas where you should be adding some more documentations on the go. Yeah, and I think this was already, I think Santika already mentioned this, but um, I think with AI also, or with all these integrations into code editors, it's becoming relatively easier, I would say, to write the documentation, especially if you give it some kind of initial idea, then it can populate, for example, the repetitive steps or repetitive text, then yeah, you could also try to use that to create that initial boilerplate document for your software, for your data, depending on, yeah, whether you like or not to use AI for that purpose.
I recently wrote, I mean, there is a stance where open source is kind of overwhelmed in general, the documentation bits regarding the contributions done via an LLM, like generated via an LLM. So
Mm.
it is probably a good time for us as software builders, consumers, maintainers, and researchers to start thinking, do I need a contribution guideline which says what are AI contribution guidelines for my project? And I have written one of these guidelines, but I'm going to share the entire link, which has all kinds of links and the measures, like how you want to treat your project in a way that it is consumer facing. You're not overwhelmed with the Gen AI contribution, but at the same time, you're able to uh, accelerate the building of the software and not getting
Mm.
consumed into the low velocity. So I feel that is something very much new, and we are learning every single day what agents are capable of. Does agents.md actually function, or we can incorporate more understanding to them, but a good nudge to us and our mental models that we need to start thinking about those kind of documentations as well while building softwares or maintaining them.
Yeah, I haven't really tried any of these agents MD, but yeah, I've heard of those, so that might be good to look into. Also very nice. I really like the contributing guidelines to data journey, Santika.
Appreciate it. And your feedbacks are always like, I'm all eyes and ears looking for feedback and improving around software.
Yeah, that's another point, like you just shared. So like the wikis on GitHub, that's another place where you can really document these kind of stuff, like the example that Santika just shared. That's another place where you can start writing your document. Wikis, if you're familiar with Markdown, uh, they follow the same approach or style to writing. And then there are also, like, if your project is like a community project on one of these hosting repos, so I'll refer to GitHub. You can also enable GitHub discussions, and if you're like trying to engage with your community, that might be another place. that is related to your software or the project that is hosted on GitHub. That is another place to have all these discussions recorded. I don't think they're enabled by default. You have to go into the settings and enable these GitHub discussions if you'd like to see some community inputs on your repository. Um, I would like to discuss at a point with your community. So that's another place.
Right. I do see some of your thoughts, and should you wish to come unmute, I'm gonna always repeat it because I love sharing. If you want to come unmute, go ahead, and nothing is right or wrong. We are all in the space in a safe learning environment. So we are up for like having healthy discussions. If you have any questions or you have any queries, and do not have to wait till the end of the session. So please go ahead and drop it on the pharma pad or come on mute and share your thoughts. I'm gonna try keeping up and reading some of your thoughts here. I usually use README notes and inline comments in the code perfect. I think that's very good starting point, not to be, as Sanjit mentioned, not to be overwhelmed with the process. You can always turn your code comments into a sustainable README. That is also an option. Or while you code, you can just have bullet points that could be further drilled down and synthesized into a markdown instance. So both of these are bidirectional form of input and out and consumption. Very cool. I usually use genome transcription analysis. So I am not aware of that. So I'm gonna look that up. That sounds pretty cool. Thanks for sharing that. And into documentation for research results, I think this is the most popular one that gets documented for sure. Research outcomes, and the change incorporated from the software or your data. And they go like kind of hand in hand, I reckon, but I do not come from a very academic background, more on the sides of development. So I love that insight in that. Alrighty. We will continue with our session, but should you have any thoughts running in your mind, please go ahead and share it with us, and we will come back to
Okay, cool. So yeah, the third scenario. So think of this researcher who has all these multiple tasks. So they are working in a chemical laboratory, and they do a survey to record some results, or to collect some results for their research work. They're also recording some patient demographics and also working some creating and working some medical records. So they are kind of here working with multiple different types of um, data, generating some and trying to analyze some. So it would be very useful to have specific storage locations for all these different types of data and research outputs that they are generating. So the storage locations are essentially called as repositories, and repositories can be very useful to store your data, your results, your code, or analysis that you create and compile software. The benefit of having specific locations for storing all this information rather than dumping it all in like one folder on your computer is that it becomes really easy to, first of all, segregate all this information, and then it becomes, once it's segregated and much more organized, it becomes easier to share with your collaborators, with members of your research group, and that way it's also easier to find because you organized all this information really well. And then what are some of the places where you can start storing such research outputs? So one of them is Zenodo. Zenodo is like an archiving repository to archive individual releases of your software, of your data, or of your publications. A very simple example of starting to use, say, Zenodo would be to, if you're preparing any slides for your presentations, you can dump your slides in Zenodo. It gives you a nice DOI. We'll come to DOI a bit later, but basically, Zenodo is one such repository to archive um, the different outputs of your research. So it looks like this. I've taken a screenshot from the Turing Way Zenodo community, and you can provide a nice description of what this deposit that you're making to Zenodo is about and who authored it, who are the co-authors. You can also link it to their ORCID IDs and make sure there is like a version associated with this uh, item that you're submitting to Zenodo. Another repository is GitHub. GitHub is more popular with storing software or data. Um, you can also store results on it. You can, in some cases, or if you'd like to, you can also create a website based on what you have stored. So you can use the inbuilt GitHub pages to like build a website for your software data results, whatever that is. And again, this makes it very much easier, especially if you're working in a collaborative environment. If you're working with a group of people, it becomes really easy to like push changes to this one common hosting repository, and everyone is aware of who's working on what and what is getting stored on this repository. So that becomes like a common source to put things into. Okay, so I'm going to pause here and would like to invite you to reflect on if or find if there are any Zenodo or GitHub repositories for any software or data set that you use. So irrespective of which domain you are in, what you could do is you can search, like you can put the name of your domain and then say GitHub or Zenodo and see what you find in that search. You might come across a lot of repositories that are relevant to your field. So yeah, go ahead, do that.
And yeah, you can continue sharing your thoughts from the section from the line number 91. Try your initials or your name. Should you wish to be anonymous, that's also fine. And yeah, I'm gonna just keep a track once those thoughts arrive here and we will discuss them. Yeah, I should look into Zenodo. I have never done it. It's a good point. I was actually looking into the ways that I could actually incorporate in my workflow. GitHub Pages is such a sweet and quick, accessible implementation of taking your README from a markdown to a hosted web accessible link out there in just click a few buttons. So it's really powerful if you want to host your README directly
Mhm.
on the internet. And plus, you can also have a little complex ways of doing your documentation. Like you can use Sphinx, which was widely used. And I know a lot of softwares who have their documentations built on top. And that is also very great way and an open source project that I really like to explore.
Yeah, I think
What
when,
are you?
sorry, go ahead.
No. I can keep talking, so go ahead.
I think when you start to look at this whole set of tools a bit more holistically, you will realize that whatever principles we are talking about, they all connect in the end. So, um, for example, if we look at GitHub as a tool, I'm saying, uh, inherently, it expects you to document your stuff. It expects you to Sorry, I'm just getting a bit distracted. So it expects you to document your stuff. You give it a very nice README. You can create like GitHub pages, deposit your software code, like also organize yourself nicely by using all these different files and folder structures that you can use on your um, on your tools. Um, yeah,
Yeah, I
but
think at the end it is something what works best
mm,
and is most conducive for the time you have, perhaps the amount of maintainability that it needs, how complex or not complex you want your workflow to be in. So the tools and technologies are there, and it will keep growing. The ecosystem is growing at as we speak, probably, and we will have two more documentation piece of tool and software coming up. The whole idea is I want to document, and it should be accessible to the users who are consuming. And it could be as simple as a README, it could be as simple as you sharing a document. That is also an acceptable way. When there was no GitHub, we were much on pen and paper or shared notes and links and hand done prints. We're not going back. I'm not suggesting that we go back, but everything what we talked about is a digital way of documenting things, and so that we it's accessible globally, and I can access from this part of the world your work, which is amazing. I mean, internet lets us do those amazing bits and pieces, and magically I can consume your software and build on top of it. uh, how incredible is it?
also like
Sometimes if
yeah, it also like lowers the barrier to entry when you have a well documented project out in the open in open source. um, if there is like, as you mentioned, Santika, if someone is sitting in one corner of the world and another person is consuming the software in another part of the world, if you have all these nice principles embedded and you're giving all these people a pathway to enter into the work that you're doing, and then they get a chance to develop the work further. So I think open source is the reason why I got to learn all this, because I don't have a background in software engineering. I just ended up doing it because of open source and because there was so many chances to learn from all these experienced developer who were developing things in the open there for you to consume, and happy to provide all the feedback. Sometimes it can be really intimidating, especially if you're new to the field and you don't know where to start. So when I was starting out, I would like even create pull requests about typos that I find on repositories, and that way, even if that's not a very big contribution, but at least I got to learn how this whole thing works. What does it mean to create a pull request? What does it mean to ask for a review, request a review, and then just understanding that whole cycle. Um, that became possible because all this work was in the open, and there were developers or maintainers open to the idea of getting contributions across the globe. So it for me, I really um, feel that it has been a very great learning tool. Uh, and yeah, I think if you embed all these practices in your research as well, and if especially if it's something that you're building for the community to consume, you are going to inspire a lot of the next generation that's coming, and you're going to create this pathway for them to also follow along. And yeah, there is always this question about maintenance and the maintainer burnout when it comes to open source. Um, but I guess there used to be like all these very nice programs in the past. I think they still do it now. The Outreachy program, the Google Summer of Code, and similar programs that really focused on entry level open source contributions and pairing up all these. people who are applying for for these programs with experienced developers and giving them a chance to learn open source. And I feel like the best part of it was all these boundaries that you could cross without like really leaving the place that you are working or studying at, and still being able to contribute to across the globe. So yeah.
Right, that makes me reflect so much on how the journey for me, perhaps some of us in this session have a journey that they want to share. Like, what was your contribution, first contributions? Like, doesn't have to be opening a PR. It could be as simple as I found a data set and I pointed out a abnormal entity and I was able to add a comment to it and fix that, or it is a discussion that I opened. So, any of those experiences from your domain or your past or something that you're working on that you want to bring and share with us? Or maybe it could be something that you want to further learn and advance your skills in and contribute to. It could be either. It doesn't have to be always that we have done it and we want to share it. It could be something you want to do it and you want to share it. So we can also probably have resources for you to cross-refer and accelerate that process.
Yeah, hello,
Hey,
good evening. Yeah, it was very nice presentation by Saranjeet and very good hosting by you, Santika. So
yeah.
I have one question actually related to activity two, and I already added in the framework that since you replied that it's a good thing to document the research data. Am I audible?
Yes, you are loud and clear.
Okay, thanks for the confirmation. So apart from that, actually, I may be unaware that means what else data that we usually encounter in our daily work routine that could be also be documented, right? So I just want some more examples from you in your daily life. What other data set that you encounter and which needs to be documented? So if you throw some lights on that, so it could quite easier for us means for me to understand better how to document the other data than the research results.
Right. I am pulling out one example that I have top of my mind. So I like to use intake as one of my mediums to catalog the data that I use for my projects. And it looks something like this, which means I have a simple, if you were able to access that, I say what is the type of data, it is a CSV, which I say, and what is the source, what is the path that I'm locally storing it, some information regarding the description, what it could be, the arguments that it hosts, the data types, and the schema. So intake has the package and drivers, a lot of drivers incorporated in the back, so you can pull the data from the internet right onto your workflow by a few commands in your Python script or whichever choice of language. And this is an example of what you can document, but there are more comprehensive examples out there. Does that make sense or is helpful?
Yeah, I've gone through that. Yeah, it's means helpful to understand. But if you have any other example than that, I appreciate that also. Or maybe
Perfect.
Saranjeet can want to share something, ma'am. So you can also share any other example.
Um, I don't really work a lot with data except when it's about analyzing something. But I have also heard of so I think if you look up research data management plans, you might come across things that different research groups or different types of data that different research groups might be documenting. So, okay, let me see if I can find something on that.
I think other place that you
So,
can really look into is Kaggle. I really love their data
yeah.
card. If you're familiar
Mhm.
with that, it talks about the collaborators, the authors, the DOI, the compliance, the province, and in depth. This could be another example that you can replicate in your data or software practices as well.
Yeah, I'm also trying to understand the question that Zayul, hope I'm pronouncing your name correctly, is asking. So you would like to know what are the different types of data sets people can document, or are you looking for a specific discipline? Are you talking of something very specific, or?
No, no, no. I'm asking about the general data sets type. Yeah, data set types should be there, but it's not any specific domain. It means any kind of data set other than the research. Just like Santika ma'am has shared
Oh,
software
okay.
package. Any other example other than the software package and research? What else data we can document? And yeah, and the pronunciation of my name is Ziaul.
Okay. Yeah, I can't think something else, like anything else on the top of my mind, just because I don't work a lot with data or stuff outside research. But yeah, I'll keep that in mind. If I find something, I can put it in the Prama pad, if that's okay.
Yeah, yeah, thank you so much. Actually, I got the answer. The
Okay.
second link that Santika ma'am has shared, it is perfectly fine. So I got my answer. Thank you so much.
All right.
It's a
Sounds
general kind
lovely.
of example. Yeah.
Yep, and not restricted to that. The amount that you can, the more, the better. That's what it goes in the world of data. Um, just have information, just have it somewhere documented so you can forget about it and recollect about it. Lovely. I am looking at the answers and thanks for sharing the different documentation types, the communities around it, and your reflections on them. We will move on to our session, and then we will have a final activity for us to do at the end.
Yep. Okay, so the final part is about, so we have so far talked about the importance of understanding what's metadata and where it's useful, the importance of documenting our work. And then we also talked a bit about where to like store all the outputs, research output that we produce. So I have been using the word research throughout the session, but I guess all of these practices and principles can apply outside research as well, in the open source or in general in the software development world as well. Um, so yeah, f- there it's not that whatever I'm saying here is restricted only to research. It's just because I'm coming from that background. I've been using that word a lot, I realize now. Um, so yeah, the last scenario that I would like to talk to you about was about this scenario where there is not just one researcher, but there is like a whole fleet of researchers, a group of researchers in a lab, or a group of, let's say, developers, or a group of collaborators, or a team working on a particular problem. And then each of these people have been developing different types of output. So uh, the patient demographic data, survey data, output from the laboratory experiments or medical records. So all of these individual people are creating all these different records and trying to store them. So how do we like uniquely identify the output that is created by in an individual? So it's possible to do so using persistent identifiers. So persistent identifiers are like a unique reference to a particular resource associated with a work that an individual has done. and they uniquely point to a digital entity. The advantage of having persistent identifiers are that they are also machine readable. So one of the popular identifiers or persistent identifiers in research is ORCID. So if any of us in the room today have been in the research world or have worked on research projects, you might have heard the term ORCID or ORCID ID, and it stands for Open Researcher and Contributor Identifier. And basically, it's a 16-digit numeric code. So on the right on my screen, you can see that's my ORCID account, and below that, there is this https orchid.org and then a 16-digit numeric code. So this code uniquely identifies me as a researcher, and then whenever I am creating a research output, it can be like a paper or a report or any form of research output, I can associate it to my ORCID ID, and that way, it that digital output is uniquely attached to my profile. So it will help to identify all these researchers uniquely and associate the output that they are creating through their research. Um, um, and also we can trace back who created which output using this. So if you don't have an ORCID account yet, you can create one by going to orchid.org, and then you can start using it along with your along with the open source or open outputs that you produce. So some features of ORCID include it's like a unique ID, and it links researchers. I'm saying researchers again and again, but it let's say open scientists to their research and related outputs. The beauty of it is that it lasts throughout your career. So even if you change organizations or you move to a different project or a different grant, you can connect all the work that you have done so far with your ORCID, and that way it creates like a history or your portfolio of the work that you've done in the past. And yeah, so even if over time you change your organization or you move into a different role, you can still trace back and keep record of what you had done in the past role. Okay, another one, another identifier that's also um, relatively popular is the digital object identifier or DOI. So this can be used or a DOI can be used to cite a lot of things. Like DOIs can be used to cite your software, journal articles. So if you have ever like worked in research or worked with people in research or published a paper, you might have come across this DOI that's associated to this published version. So DOIs can be used to cite most of these outputs like data, software, articles, different types of medias, even slides or blog posts. And they are provided and maintained by this international organization for standardization. And if you want to look up a bit more, you can go to doi.org and you get more information on how to resolve a DOI. The features of DOI include, so basically they are static pointers to anything digitally available. So any documents on the internet, everything will get like can be associated with a unique identifier or a unique DOI. When you create a DOI, it gives you a link, and then if you click on that link, you can trace back to whichever version it was. Even if things have changed since, you should still be able to trace back to the earlier version. and it makes it really useful to citing using DOI makes it really useful to find research outputs and find them uniquely as well. So here's an example of a DOI. So here, over here on the second line, 10.5067. So if I click on this link over here, it will always take me to a certain web page, and the web page is on the right on the screen. So whenever I click on the screen on this link, it will take me to this particular web page, as both are uniquely linked using the DOI. Okay, I'm going to skip over that slide because it's mostly what I have just mentioned. This last final activity is about finding and resolving a DOI. I'm going to move to this page, but I have also pasted this activity in Fremapad. I'm forgetting the line number now. But basically the activity is about finding and resolving a DOI. So what you need to do is, for any software data set or research paper that you use, go and find what the DOI is. You would usually find this information on, if there is like a repository, you should find it there, or if it's a research paper, you would see something like doi.org somewhere written on it. So try to find that number. And then once you have found that number, you can go to this www.doi.org and scroll to the bottom of the page and click on try resolving a DOI name. So once you do that, and you click on submit, it will automatically take you to the page that explains and contains the cited data. So I think this activity is also on the Fremapad. So I'll just quickly stop sharing and mention the line number where.
I have added the link. That's 78
Okay.
on the
So,
From pad.
okay. Thank you. Yeah. So if
Most
you
welcome.
follow those steps, yeah. And then you can start with, if you don't have anything to check the DOI for, there's also a link I've given. I think it's on line 84. You can copy that link, you can open that link, find the DOI, locate the DOI on it, and then go to doi.org and put it over there and see what happens.
Sanjeet, this activity is quite interesting. Actually, I'm going to check my own paper uh, with this activity. But one thing I want to ask: can I generate can we generate DUI for our work that are presentations and a video? Can we
Yeah,
generate DUI for them?
yeah,
If they are not listed in any PubMed like database, so is it possible?
Uh, I yeah, so what I would usually do is, for presentations or any other output, I would usually deposit them on Zenodo. And when you do that, Zenodo does ask if you have a DOI or do you need to create one, and then it creates one for you if you'd like to use that.
Yeah, that's great. Thanks a lot. This is totally a new thing that I just know from you. So thank you so much for that.
Also, I think if you would like to get DOIs, if you have heard of this organization called DataSite, they're like, they cover a lot of stuff around registering DOIs, and I think Zenodo is like a partner with DataSite. I'm not sure, but I think they are connected somehow. And DataSite is kind of responsible for creating all these DOIs that we.
Okay, yeah, can you share the link for that data site if you
Yeah, and
have?
then
Mm.
many organizations also have like a affiliate, not affiliation, or are connected to DataSite. So you might, if you're working in a organization that is already using DataSite, you can just check, put the name of your organization and see if it's like a member or something.
Yeah,
While
perfect.
we lovely. While we continue this exercise in the background, we also have a section, just a reminder to share any questions or places that you have any further doubts or queries. You could also drop that. We, I believe we have 10 minutes on the clock. Prasid, is that right? In my time zone, I'm just checking. Okay.
Yes,
Yeah,
9 minutes.
9 more minutes. Yeah,
Ah,
I
apologies.
left I left the last part um, as open discussion if people had any questions or thoughts or any feedback.
Right. The stage is open. Should you want to discuss, have any questions for us to reflect on, share any experiences uh, that is connected to our session today, and you want to bring it to the audience being all of us in this amazing session. And that's about it. We can have the shared insights. And Sanjit, I will hand it over to you for the insights if anybody comes up and would like to share it. And then Q&A. I think I do not see any questions yet, but line number 186 is where we can find your questions should you want to add any there. Oh yeah, absolutely. A lot of labeling. I do collect a lot of stones, something that I really enjoy when I go for my hikes. And I have been trying to find a way to add markers and labels to them via format of a picture. Not like I cannot carry them all the time, but I carry them, snap a picture, and add where was it, what time should I remember that, which country, why I collected at the first place, and add those information as part of my journaling process.
That's
Yeah, I
awesome.
have been.
I
Okay.
was also always curious to know how people implement metadata in their own lives, in things that are not technical. Here at home, we do a lot of labeling as well, even inside the fridge, because you're always thinking on if someone comes over, and especially because here in the house we have those switches, and they are paired up, and we never know which lights they turn on, and so we add labels there as well to like if someone comes over, they know which switch to turn on to get this light on. Yeah.
I think I saw this label generator on Kickstarter, like a tiny machine where you can just rely on. That is so amazing, and I would be like obsessed. Label everything. Label the potato. Label where I'm going today.
I would like when I was quite young, I would in my kitchen where I grew up in the house, I would like put all these labels on all the boxes, like this is rice, this is so and so dal, this is some spice XYZ. And I remember like we used to have those steel aluminium kitchen boxes, and I would just write labels on them, making it a bit easier for my mom to find things whenever she needed. Yeah.
Okay, we are 5 minutes to the end of the call. I see we have an interesting question in the Framer pads.
I'm
Should we
just gonna
go
read
to
it
this
loud for
question?
all of
I
us.
think-
Sorry.
I was just checking if we went through this topic or this
I,
question.
I, I think we did touch. The question is, I haven't utilized Zenodo yet, but I have been using OSF for documenting research? What and when should I utilize each of them? And thank you for the lovely class and 2 hearts.
Okay, so I would say stick to something that you're already using. If you get all the required functionalities, and if it serves your purpose, go ahead with OSF. I mentioned Zenodo as something that I personally use a lot, be it depositing my slides or some reports that I prepare, and I don't know which other place I want to put this. I would just go for Zenodo. Also, don't really overwhelm yourself with a lot of tools, because many of these tools are serving a similar purpose. So if you have like one tool that you have figured out, okay, this is what I'm going to follow and this is where I'm going to deposit my stuff, I would say build your profile there, and don't overwhelm yourself with with like creating accounts on too many tools, and then um, it also becomes really hard to maintain all these different online portfolios that you create for yourself. So decide on a few. I would say one or two is more than enough, and then continue with that. I've not used OSF before, but if it's something that is useful for you in your domain, in your area of work, feel free to go with that.
Love that insight. Less is more sometimes, so it's okay.
Yeah,
But
I
we
end
just
up
have one.
like it's a thing that I do. Like when I'm recommended things, I end up creating an account on all these different tools, and then I hardly come back to use them unless I see like the real benefit of using it, or I have to also remember that okay, this is a new tool, and then now I have to like start using it. So just start with one or two, and then see how it goes from there.
And I think we have 120 seconds, I hope, on the clock, and I would give it to Crossbilly for the closing of our today's session.
All right. Thank you all for coming. That was amazing. Thank you, Sarajit, for your expertise, and Santik for your facilitation. Amazing session. Pristine. Thank you so much. For our participants, our next cohort call will be about open data. Is it April 30? No, that's wrong. Okay. Is it? Yeah, April 30. Yeah, that's correct. I'm lost in time. It is April 30, open data at 3 p.m. UTC, same time. So I'll wait to hear in 2 days. And about coaching sessions, please sign up with 3 days in advance, so the coaches have time to read your project, read about yourself, about you. And then the next coaching sessions available for grabs are May 4th at 6 p.m. UTC. Please sign up by this Friday, May 1st. And the next one will be May 6th at 2 and 6 p.m. UTC. Please sign up by Monday. Let me send you the link here in the chat. This is the spreadsheet that we are using. Just fill out the template talking about you and your project, your main question, and comment in the spreadsheet with the link for the session that you want. And that's it.
Dot on the clock. Love that. Such euphoria. Yay! Well, thanks everyone for joining today's session. I hope you had some takeaways, something that you learned, something you're going to implement. And we're always open after the session to hear your thoughts. Bring them on Slack, I believe. Do we have Slacks? And everyone of you are on Slack. And hope to see you all for the next session. Bye.
Bye.